Do you know when your car is running or diesel generator is running, how much is the temperature inside the piston chamber or diesel engine? You will be surprised to see that number. We are going to see. And to manage or to maintain the temperature, normal temperature, so that it will not melt. Okay, I'm telling you, melt. It will melt if you will not take out that heat from the diesel engine. Otherwise, entire diesel engine will melt. You will see the temperature. And then main important part is cooling system. What are the functions of cooling system? First is absorption. What it absorbs? Obviously heat. I told you, if you don't absorb the heat from the engine, it will melt down. Okay, because temperature will keep on building up. Okay, and at one point it will melt the metal. So absorbs heat from the liners. Okay, the liners of the radiator. Okay, or even liners of the jacket of the engine. Okay, so like this jacket, in the engine has water jacket. Okay, so that is absorbing heat from the engine. Now next is circulation. What does it circulate? It circulates coolant throughout the system. Okay, I told you entire jacket is there around the engine, so it will circulate the water. Then control. What it will control? Maintains coolant temperature in the desired range. Okay, so you know, it's only not metal, even there are some plastic parts are also there, or rubber part, or insulation is there. If this heat goes up beyond the limit, the engine will shut down. So to avoid that, we should maintain the diesel engine temperature at some extent, otherwise it will not work. Okay, have you seen at roadside many cars are breaking down, and then when they open their bonnet, what happens? The heat. Okay, smoke or fumes. So these kind of things happens just because its coolant or cooling system is not working properly. So it should control and maintain the temperature at the desired level. Then dissipation. Simply, what does it dissipate? The heat. Okay, releases, absorb heat to the atmosphere or raw water. Okay, whatever heat it has absorbed, it will release it to the atmosphere. Okay, next, cooling system key components. Now, what are the components? First is fluid or flow components. The flowing component, the water pump. Obviously, water, to circulate the water, we need water pump. Then hoses are there. Then flex master couplings is there. Radiator, we will see each and everything in detail. Radiator we will see in detail what is its function and how does it function. Okay, then radiator fan, then for shrouds, then belts and pulleys. Okay, then cooling and control efficiency. Then how does it maintain cooling and control efficiency? The parts, thermostat will check the temperature all the time, and it will switch. Okay, what it will switch, we will see. The pump, water pump for the circulation, we will see. Then pressure cap. Okay, pressure cap, it has a function. It's not a simple thing, only pressure cap. Then heat exchanger is there. Then heat exchanger will exchange the heat from water or from other media, which will be used as coolant. So it will exchange the heat. For bigger engines, this heat exchanger is used. Okay, the same water is not, so water like in our chillers also, wherever air conditioning is there, chillers are, so coolant is different, and then heat exchangers are there which will absorb these coolants will absorb the heat from the water. No, the water will absorb heat from the coolant. Okay, so heat exchangers are there, water heat exchangers. Then coolant system. Okay, we'll see. Then additional cooling support, oil coolers, coolant used, raw water or additives are used. So what is the function of these additives, that also we will see. Now important, the cycle. Okay, here I have shown in very detail the cycle. So it will start from radiator core. Okay, so if you want to see radiator, so this is a radiator core. Okay, so it will start from here, radiator core, then radiator bottom tank. Core is like our core, this is our core, like stomach and this thing. So like radiator has a core, middle part, then radiator bottom tank, then water pump, water header, then oil cooler, then cylinder liners are there, then cylinder head, water manifolds, thermostat, which will check the temperature and switch the thing. What? Water pump. So if, see, look at here, if temperature is proper, it will bypass the water to directly water pump. If temperature is higher, it happens. You will see in the animation. In next video, we'll see that. If water temperature is very high, then it will directly switch that water or to radiator or radiator top tank. So it will go into radiator. In radiator, what happens? Heat exchangers, it will cool down the heat, and radiator, it will come down to bottom tank. Okay. So hot water goes up and cold water goes down. That is the natural phenomena. Okay, cold water is heavier than hot water. So that is why bottom tank. From that, we want cool water, right? To cool down the engine. So from bottom tank, we have a pump. So it will pump cool water to its jacket, oil cooler, cylinder liners or headers. These are the things where heat goes very high. Then here, see, in here, corrosion resistor. Okay, water is circulating. I told you, water, if anything comes in contact with water, any metal, it will corrode or oxidation will happen. To stop that, corrosion resistors are used. Then air compressors are there to compress the air so that it will help to push the water. Okay. Then after coolers are there. After cooler we have seen. After cooler, where it is installed, whenever these flue gases are rotating, are turbocharger, and after that it is heated. Okay, turbochargers, the rotation, we have seen the speed of turbocharger is up to 100,000 rpm, revolutions per minute. In 1 minute, 100,000 rpm. Okay, revolutions per minute. So because of that, the temperature goes up, and that is why we need after cooler. Okay. Now this is just the small diagram of the circulation of coolant. Now then, I told you how much amount of heat is generated. Tremendous amount of heat is generated during engine operation. How much? Up to 3500 degree Fahrenheit, or in degree Celsius 1927 degrees to 4000 Fahrenheit, or 2204 degrees Celsius, 2200, more than that, degree Celsius. If you don't control this heat, it will definitely melt down your car, okay, or your generator. You will not see the generator again. Okay, it will melt down. But you have the protection system or protective system. Whenever temperature goes up, it will shut down automatically. It happens in terms of car. You must have seen cars are breaking down besides the road because of high heat, because coolant, the level of coolant will go down. So many reasons are there. Okay, or even circulation, or even fan is not working, the radiator fan, we will see. So 1/3 heat converted into useful work. Okay, I told you, if air molecules or these molecules are heated, what happens? Okay, or fuel molecules are heated, what happens? Its velocity will increase, and it will bombard on what? On our piston. It will push down the piston. High pressure is created because of heat. So this heat is used, converted into useful work to bring down the piston for the piston operation, so that engine is rotated. Okay, because of piston is doing that. Now useful work is 30%, then 33%, 1/3. 33% is his heat passes through exhaust gases. You might have seen at the exit of flue gases or any chimney of any diesel generator, if there are any dry leaves, those are catching fires. Incidents happened because it has high temperature exhaust gases. Then we try to control it, right? But still it is high temperature. Then heat dissipated by cooling system or back or oil fan. Okay. So cooling system is dissipating heat. Okay, even oil is dissipating heat. Okay, in the radiator. So the radiator is a cooling system. We'll see. So one third, one third, one third. Okay. Next, radiator. I told you. So now, where is the location of radiator? This is a radiator. This is your engine. This is our alternator, and this is our radiator, which keeps our water cool. Now, basic function. Okay. So basic function of radiator: water storage and excess heat dissipation. First thing is water storage. Then it has fins. Okay, many fins are there. Why fins? Because we need to increase the surface area to dissipate the heat. Okay, do you know simple example? Okay, you have seen cup and saucer. So in India, okay, people use a saucer, just put, or even our soup, we put it in a bigger pan, not pan, bigger pot or utensil. So we put it. Now what happens? Its surface area increases and the heat dissipation rate goes up. And that is the reason the tea or coffee in the saucer, the temperature comes down fast. Or even your soup, the temperature will come down faster because of its surface area. It dissipates heat more. So that is the reason it has fins, and it will, what it will do? Excess heat dissipation it will do. Now, rate of absorption equal to rate of dissipation. Whatever heat it is absorbing from the water, it will dissipate it out to the atmosphere, okay, through these fins. And after that, we have a fan. So fan is blowing air on these fins. Or even in your car, if you see, if car is stationary, the fan will rotate and it will cool down that radiator, or rather water inside the radiator. Okay, so consists of three parts: heat transfer core, center, then inlet tank and bottom tank. Upper, okay, these 1, 2 and 3. Now normal flow of coolant from top to bottom through core, simple, top to bottom coolant will automatically flow. Natural, what you call it, natural circulation of water. Hot water goes up because it becomes lighter. Hot air, we have seen in first lecture, hot air is thin, and that is why it has less oxygen. The same way, hot water is thin, that is why it has less weight, it will go up. Okay, and cold water is thick, okay, dense, that is why it will come down. So normal flow, then top tank, bottom tank, water storage areas. So these are the components of radiator. So you know now the function of radiator to dissipate the heat. So this is the radiator, there is a fan, there are fins, okay, then filters and all those things are there. You just go and see in your generator or in your car, the radiator, the fins, lot of fins are there, this kind of structure. Okay, next is radiator cap. So this is the radiator cap. Whenever your car is down because of high heat, okay, in the engine, don't open the radiator cap. It is hazardous. It will just blow out the coolant and it will burn your skin. Okay, so don't do that. Just wait, okay, till it cools down, and then at the proper temperature open it, or take the professional advice. Don't do that. Go to mechanic. Okay. Now, so this is the radiator cap you have seen. This is at the top of the radiator. So conventional caps, to use opening of tank to avoid splashing or loss of coolant, should not come out. That is why cap is there. Okay. Then prevent dirt entry. Dirt should not enter in the water. Okay, or coolant we say. Why I am saying coolant? Because we are putting additives in that, so that its circulation rate, its heat absorption rate will increase. Okay. Then to facilitate the checking and refilling of coolant. So we want to check or refill the coolant. It is facilitating that. Then modern caps. Nowadays, modern caps we have. What modern caps are doing? Added functions. Maintain positive pressure on system during operation. It maintains positive pressure on the system. Then, okay. Then prevent formation of vacuum when system cools down. So if system is cooling down, what happens? Vacuum will get created. Okay. See, I told you, if anything heats up, its molecule expands or it started running here and there faster. So it becomes thin. It needs more area. If it cools down, it needs less area. You might have seen the water bottle. If you take a water bottle and if you fill it till the brim and seal the water bottle, okay, with the lid, okay, what happens, or the cap, what happens if you put it in the fridge? It will change its what shape? It will bulge, because what happens, if temperature goes down, its volume, it will increase the volume, the area it will occupy more. That is why if you want to put a water or water bottle inside the freezer, always keep it not till the brim, keep some space at the top so that it will facilitate the expansion of water. The same way, if its temperature goes up, what happens, it will take more volume or more space. If temperature goes down, it will take less volume. So what will happen? Less volume, the vacuum will be created, and what it needs to be filled in that, obviously air. So this cap will facilitate the air inside. So this is the modern cap. Okay. So it will avoid the what? The vacuum formation in the system. Then prevent boiling of coolant at altitudes. Okay, like in Himalayan ranges, what will happen at altitude? It will boil. So prevents boiling of coolant at altitudes. Okay, the cap, simple thing. Okay, how it will do? It will tightly. Okay, it will not let out that coolant, so that it will not give the space. So its heat absorption capacity will increase. Its boiling point will increase. Okay, not at 100 degrees Celsius, it will boil at more than that temperature, so that it will not boil. So it will prevent, so that because of that pressure, if pressure goes up, its boiling point also goes up. Okay, this is the basic thermodynamics. Okay. Now minimize after boil resistance loss of coolant, elevates boiling point to cool of coolant. I just told you, if pressure, it will put a pressure, keep it closed, its boiling point will increase. Okay, you have seen a radiator cap. It's not a simple thing, just a cap. No, it's not just a cap. It has these functions. Okay. Now, radiator cap, need to pressurize cooling system. How? Water boils at 212 degree Fahrenheit or 100 degrees Celsius. Everyone knows. Okay. At sea level, okay, not at altitude. So boiling point can be raised by 3 degree Fahrenheit per psi rise. If pressure goes up, boiling point will also go up by 3 degree Fahrenheit per psi. Psi is a pressure unit. Okay, every psi increase in pressure, it will increase the boiling point by 3 degree Fahrenheit. Then 7 psi pressure will raise boiling point to 230 degree Fahrenheit or 111 degrees Celsius. 11 degree difference, 7 psi pressure increase. Then by raising boiling point, capacity of coolant to absorb heat and cooling efficiency can be increased. It can absorb more heat. The water, same water can absorb more heat. You have seen how much is the temperature inside the engine? 2000, more than 2000 degrees Celsius. So we need to absorb it quickly, and that is why this coolant or water coolant is required. So by raising boiling point, capacity of coolant absorb heat, cooling efficiency can be increased. Water pump efficiency is more if coolant is under pressure. Okay, Obviously, at high pressure, it will absorb more heat. Now, 4 psi pressure rise, water pressure, efficiency by 10%. Water efficiency. Okay. Then pressure in cooling system reduces loss of water due to evaporation, surging and unnecessary boiling. It will seal it. So it will increase the pressure. So it will not evaporate. Okay. For evaporation, the surface should be open to air. Otherwise, evaporation will not happen. It will evaporate in air from liquid form to air in the what is gaseous form, but it needs air, it needs space, but because of this it will not happen. Pressurization accomplished by use of specially designed filler neck, the neck above it from where we put the coolant, and a pressure controlled by cap. The cap is controlling the pressure. Two valves, a pressure valve and vacuum valve. The pressure valve and vacuum valve, two valves are there. Vacuum valve will facilitate the air going inside. When water is going, level is going down, when it is cooling down, the level will go down. Okay. Then vacuum valve is opening, and then pressure valve means there are two valves in this radiator cap. It is not a simple radiator cap, I told you. So a pressure valve. Then pressure valve regulates maximum pressure, opens at excessive pressure. If pressure goes beyond the limit, it will open. Otherwise, it will burst the radiator. Okay, you see the blast of radiator. Okay, we don't want that. That is why this pressure cap. Otherwise, you will incur a lot of expenses. Okay, so to avoid that, this pressure cap will facilitate that excess pressure. It will go out there. Then built-in pressure control valve seals of cooling system. So built-in pressure control valve is there inside this radiator cap. So it is not a simple radiator cap. Okay. So in next lecture, we will see in depth how cooling system works. Thermostat. What is the function? How that motion or the water is circulating inside the radiator. We will have the animation also of that, and we will see in detail. Okay. Thank you.